guys, I hope you are all doing well. I cannot believe that we are already in our 4th week of distance learning. Kind of crazy. Even though we are in chaotic times, it seems like the time is still kind of going pretty fast. I hope you enjoyed your assignment yesterday, being able to create your own math meme. Let me tell you, some of them definitely had me laughing. So great job on those. If you have not yet gotten me your meme, please make sure that you do send me an email with it attached, because you are getting points for that assignment. Okay, so now let's go back to the wonderful world of studying matrices. Today we're going to look at something called the determinant, and the determinant only occurs when you have a square matrix. Okay, so it says every square matrix can be associated with a real number. That's called its determinant. Okay, and notice different things here. It said square matrix. That means that the number of rows by the number of columns has to be the same. So a square matrix could be something like a 2 by 2, a 3 by 3, a 4 by 4. Okay, and it says that your determinant must be a real number. It can be positive, it can be negative, it can be 0, but it has to be a real number. So we will not be seeing anything imaginary. Okay. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. And that's what this whole chapter has been about. We've been solving systems of equations. We did solving systems by graphing, then the substitution elimination, then the elimination method. Then we went ahead and created matrices. And from the matrices, what we could do was solve using Gauss-Jordan elimination. Now what they want us to do is we're going to be able to solve using this determinant. Okay, that's what we'll look at tomorrow. It's a process called Cramer's rule. Today we're just going to be able to find the determinant. Okay, what you're doing, you are taking a system of equations and turning it into what's called a coefficient matrix. Now notice the coefficients for x, the numbers before x, they are the first column. The coefficients for y, they are the second column. Now it's different than an augmented matrix. You do not include your solutions when you are creating the coefficient matrix. Now to find the determinant, and remember the determinant is just one number. If it's a 2 by 2, they're saying take a sub 1 times b sub 2. So you're multiplying in a diagonal pattern. You take a sub 1 times b sub 2 minus now a sub 2 times b sub 1. Order of operations, you would go ahead and do the multiplication first and then subtract the 2. That one number would be called your determinant. So let's go ahead and try a couple 2 by 2s. So following the formula, you always start in the upper left-hand corner. Multiply in a diagonal pattern. 2 times 2 is 4. Minus. Now you multiply again in a diagonal pattern, the other two values. 1 times negative 3 is negative 3. If you minus a negative, that changes to a plus. 4 plus 3 is 7. 7 is your determinant. Again, your determinant is just a single number. So at this point, you are done. Okay, let's find the determinant of matrix B. 2 times 2 is 4. Minus 1 times 4 is 4. 4 minus 4 is 0. So this has a determinant of 0. Next one. 0 times 4 is 0 minus 2 times 3 halves. So if I look at this, 2 times 3 halves. Remember when you multiply by a denominator, they would cancel. So all I would have left is a 3. So this is 0 minus 3, which is negative 3. So here are the 3 examples that I had for you, how you find the determinant of a 2 by 2. Notice we have one solution that's positive, one is a 0, one is a negative. They are all real numbers. Now we're going to go ahead and look at a 3 by 3. Now to me this is kind of fun. If you're doing a 3 by 3, step 1, you have to take the first column and write it on the outside of the matrix. So 0, 3, 4. Now you do the same thing with the second column. You go to the right side of the first column. So 2, negative 1, 0. So again, what I did, I took the first column, wrote it outside of the matrix. Then I took the second column, wrote it outside of the matrix as well. Now to find your determinant, you're going to start in the upper left corner. You're going to draw a line diagonal, and it has to go through 3 terms because we're looking at a 3 by 3. You multiply all of the values that are on that line. 0 times -1 is 0. 0 times 1 is 0. Plus, now I go to the second number on the top, diagonal line. Multiply all of the numbers on the diagonal. 2 times 2 is 4. 4 times 4 is 16. Plus, now I still have a number on the top, so I have to go again. And this is why you had to put those 2 columns, because you start at the upper left, then upper middle, then upper right. And every line has to go through 3 values. 1 times 3 is 3. 3 times 0 is 0. So now you add those. These are the values that I was able to obtain by drawing the lines from the top. 0 plus 16 plus 0 is 16. That's not your determinant yet. Now you have to go from the bottom. So 4 times -1 times 1 is -4. Plus, there we go, switching colors here. 0 times 2 times 0 is 0. Plus, there we go, 1 times 3 times 2. Well, 1 times 3 is 3. 3 times 2 is 6. So I add these. -4 plus 0 plus 6 is 2. Now, the way that you find the determinant is you take your first solution, so 16, minus your second solution, which is 2. 16 minus 2 is 14. That is your final answer. This is your value. That is your determinant. Okay, so again, you go ahead, start from the top, corner, middle, other corner, so left, middle, right. Draw the line through 3 numbers. You multiply them, add those together. That's your first number. Now you do the same thing, but you start with the bottom. So bottom left, middle on the bottom, bottom right. Find those values and go ahead and add them together. That's your second number. First number minus second number, that's your determinant. So one more, and that is it for the day. Then you'll have a worksheet practicing how do you find the determinant of both 2 by 2s and 3 by 3s? Because then tomorrow we'll use those determinants to actually solve systems of equations using a process called Cramer's rule. Kind of fun, okay? This is a 3 by 3. If it's a 3 by 3, step 1, you have to take the column and write it on the outside. Now you take the second column and you write it to the right of the first column. So that would be your first step. Now you start in the upper left corner, you draw a diagonal line that goes through 3 values. You multiply these values. -3 times 5 is -15. -15 times 1 is -15. Plus, now you go from the top middle. 2 times 6 is 12. 12 times 2 is 24. Plus, now you go from the upper right. 1 times 4 is 4. 4 times -3 is -12. -15 plus 24 plus a -12 is -3. So that's your first number. Now you do the same process, but you're starting from the bottom. 2 times 5 times 1 is 10. Plus, -3 times 6 is -18. -18 times -3 is +54. Plus, 1 times 4 times 2 is 8. 10 plus 54 plus 8 is 72. The way that you find the determinant, the first value, which we got was -3, minus the second value, 72. -3 minus 72 more is -75. That value is your determinants, and we are done with our lesson for today. So go ahead and work on your practice worksheet, finding determinants. Tomorrow, step 1 will be to find the determinant, and then we will use it to solve systems of equations. Hope you're having a great day. Talk to you soon.